Somebody sat you down at some point, maybe a teacher, maybe a doctor, maybe just the general hum of things everybody seems to know, and told you a very particular fact about your own heart. Of all the organs you carry around inside you, the heart is the one that never renews itself. You are born with every heart muscle cell you will ever have, the story goes. A fixed and final number handed to you before you ever took your first breath. And from that day forward, you spend it down, slowly, cell by cell, the way you might spend down a sum of money you will never again have the chance to earn back. Your skin replaces itself. Your gut lining replaces itself so often it is practically a stranger to itself by the end of a single year. Even the surface of your bones is quietly rebuilt across your lifetime, torn down and laid back down again in a slow, patient cycle most of us never think about. But your heart, you were told, is different. A closed case. Worn a little thinner every decade, its muscle wearing down the way a favorite record wears down after enough years on the turntable, but never once replaced, never refreshed, never given a single new part. The same heart, cell for cell, from your first cry to your last breath, ticking down towards some final number nobody could ever see or count, but that everybody simply assumed was there. I want to tell you tonight that this is what I was taught too, for a very long time, and that it turns out not to be true. Your heart has quietly been swapping out its own muscle cells, a few at a time, for every single year you have been alive, slowly, modestly. Nowhere near fast enough to undo real damage, and I will be honest with you about exactly how limited it is before we are through tonight, because I think the honest version is the one worth having, but real, measured, proven, in a way so strange and so unlikely that when I first read how scientists actually managed to prove it, I had to put the article down and sit with it for a minute before I believed what I had just read. I am not here to hand you a fix for anything, and I am certainly not here to frighten you about anything either. I am here to hand you something better than either of those. A truer picture of the quiet, working thing beating in your chest at this very moment. Here's where I want to take you this evening, laid out plainly so you know the shape of the road ahead. By the time we are through, I do not want you thinking of your heart as a single, fixed object you were handed once at birth and told to guard carefully until it eventually wears all the way out. I want you thinking of it instead as something that has been quietly, slowly renewing itself under your ribs this very minute, the way it has been doing without asking your permission or your attention for every year you have been alive. We are going to look at where the old idea came from and why it made perfectly good sense for a very long time. We're going to look at the strange and almost unbelievable way scientists eventually proved that idea wrong, using, of all things, the fallout from nuclear bomb tests carried out decades before most of the people reading this were even born. And then we are going to sit with what it actually means, honestly, including the parts that are more modest than you might hope. For most of the last century, doctors and scientists believed something quite reasonable about heart muscle. They believed that once you finished growing, somewhere around childhood, the muscle cells of your heart simply stopped dividing and never started again. This was not a lazy guess. Doctors built it on real, careful observation. Skin visibly heals itself in front of your eyes. A cut on your arm closes over within days, new cells crowding in to cover the gap. The lining of your gut turns over so quickly that in a sense you have a nearly new gut every handful of days. Blood cells are born and retired by the billions, day in and day out, in your bone marrow. Heart muscle showed none of that visible churn. And there was a second, sadder piece of evidence that seemed to settle the question for good. When someone suffers a heart attack and a portion of that muscle dies from being cut off from blood, the body does not grow fresh muscle back into the gap. It fills the space with scar tissue instead, tough and fibrous, doing the job of holding the wall together but never again beating the way living heart muscle beats. If the heart could make new muscle cells, the thinking went, surely this is exactly when it would do it, in the face of real and obvious damage. And it never did. So for the better part of 100 years, the idea held, and it held up well. Taught in medical schools, printed in textbooks, repeated by generations of doctors who had every reason to believe it, because every piece of visible evidence pointed the same direction. Nobody was being careless or lazy in believing it. It simply looked, from every angle available at the time, like a closed and settled question. The kind of fact so thoroughly established that nobody thought to keep testing it. The heart you were born with was, cell for cell, the heart you would die with. It was not a foolish belief, simply, as it turned out, an incomplete one, waiting on a tool nobody yet possessed to ask the question in a way a heart could actually answer. The trouble with proving it wrong was not a shortage of curiosity. Scientists wanted to know for decades whether the heart quietly made new cells somewhere along the way. Even a few, even slowly. The trouble was that heart muscle cells look almost identical whether they are decades old or brand new. There was no tag, no birthmark, nothing under a microscope that could tell you a cell's true age. You cannot ask a cell how old it is. And then, almost by accident, history itself handed researchers exactly the tool they needed, and it came from the last place anyone would have thought to look. During the 1950s and into the early 1960s, at the height of the Cold War, the world's nuclear power set off dozens of bombs above ground, out in open deserts and remote islands, testing weapons in the open air rather than underground. Nobody involved in any of that testing was thinking, even for a moment, about human hearts. They were thinking about power, about deterrence, about the tense standoff of an entire era. Each explosion released enormous amounts of energy, and along with everything else those blasts sent out, they also produced a peculiar and almost invisible byproduct. The blasts struck ordinary nitrogen high in the atmosphere and converted a small portion of it into a special heavier form of carbon called carbon-14. This was not something anyone was trying to accomplish. The extra carbon was a side effect, a kind of atmospheric residue drifting outward from every test, and it spread through the air across the entire globe within a matter of months, settling everywhere, over every continent and every ocean. Harmless in the tiny amounts involved, but detectable if you knew precisely how to look for it. By the time the testing peaked, the level of this special carbon in the world's air had nearly doubled from what it had been before any of it began. A strange and invisible fingerprint left behind on the whole of the Earth's atmosphere by a handful of tense, anxious years in human history. Here's the part that turns this from a strange historical footnote into something genuinely useful. Every living thing on Earth breathes air, or eats plants that grew from that air, or eats animals that ate those plants. And carbon from the atmosphere becomes, quite literally, the raw material your own body uses to build itself. When any new cell forms anywhere in your body, it assembles its own DNA out of carbon drawn from what you have eaten and breathed, and that carbon carries with it whatever ratio of ordinary carbon to carbon-14 happened to be floating in the air at that exact moment in history. In the years after the 1963 treaty that finally banned above-ground testing, the extra carbon-14 in the atmosphere did not vanish overnight. It began a long, steady, well-documented decline year after year as it slowly dispersed and settled out of the air, which means that the amount of carbon-14 locked into a cell's DNA on the day it was built works almost exactly like a date stamp. Measure it carefully, compare it against the known atmospheric record, and you can read back with real precision the year that particular cell was actually born. It is not so different from the way a forester can read the age of a fallen tree by counting its rings, or the way a collector can date an old bottle of wine by what is written right there on the label. Except in this case, nobody wrote a label. The atmosphere itself did the writing quietly across the whole world all through the Cold War, without anyone at the time imagining it would someday let scientists read the birthdays of cells inside a living human heart. A team of researchers, led by a scientist named Jonas Frisén, working with colleagues including Olaf Bergmann, realized exactly what this meant, and set out to do precisely that. They obtained heart tissue from people who had died at various ages, people who had been alive during the years of heaviest testing and the decades afterward, and they carefully measured the carbon-14 locked inside the DNA within the heart's muscle cells. If the old belief was correct, if every one of those cells truly dated back to childhood, then every single cell they measured should have carried a birth date matching, at the very latest, the person's own early years. That is not what they found. They found heart muscle cells with birth dates well after the person they belonged to had already grown into adulthood. Cells that by the carbon locked inside them had not existed yet when that particular heart first started beating in the womb, or in childhood, or in some cases not even by the time that person was well into their 30s or 40s. The healthy human heart, it turned out, had quietly been building new muscle cells all along, all through adult life, in defiance of a belief that had stood largely unquestioned for the better part of a century. There is a proper name for these individual heart muscle cells, and I want to give it to you once, the way I like to hand you the real word for a thing before I set it gently aside for the rest of our time together tonight. They are called cardiomyocytes. After tonight, I will mostly just call them what they are. Heart muscle cells, the little muscle cells of your heart, working, and it turns out, occasionally being replaced, quietly, all your life long. What struck the researchers most, I think, was not simply that renewal was happening at all, but how carefully the evidence held together once they looked closely. The newer cells were not clustered in one convenient corner of the heart, as if some leftover patch of childhood tissue had simply been slow to finish growing. They were scattered through the muscle in a pattern consistent with an ongoing, low-level process running quietly across the whole organ, year after year, in people who had lived through entirely ordinary lives with entirely ordinary hearts. This was not a curiosity found in a rare handful of unusual patients. It showed up again and again, in person after person, which is exactly the kind of repetition that turns a strange finding into a genuine, trustworthy fact about how a healthy human heart actually works. Now, before I go any further, if this is landing for you the way it landed for me, go ahead and tap that like button. It costs you nothing and it helps somebody else out there stumble onto this the way you just did. Now, back to the heart. Here's where I want to be as precise with you as the actual research allows, because the size of this renewal is exactly what makes it trustworthy, rather than the vague, sweeping claim you sometimes hear tossed around. In a young adult, somewhere around age 25, roughly 1 out of every 100 heart muscle cells gets replaced with a freshly built one over the course of a year. That is already a small number, and it does not stay even that high. As the decades pass, that yearly rate of renewal slows further, so that by around age 75, it has eased down to somewhere under half of 1% of the heart's muscle cells being replaced in a given year. Add all of that up every year, across an entire lifetime, from childhood all the way into old age, and the total works out to something genuinely remarkable and genuinely modest at the same time. For most people, fewer than half of the muscle cells present in an older heart are the original ones they were born with. The rest arrived later, one small batch at a time, across decades, so quietly that nothing about the process ever announced itself. Think about what that actually means laid out across a whole life. A person born in the middle of the last century has, by the time they reach their 70s or 80s, been carrying a heart that is genuinely a mixture, part original, built before they ever took a single step, and part newly made, added in slowly across 7 or 8 decades of ordinary living, one small, unhurried batch of cells at a time. Nobody planned it that way. Nobody could feel it happening even once along the way. This is not a heart rebuilding itself in any dramatic sense. Picture instead a slow river of new cells joining a much older population, so gradual that you could live your entire life without ever once being able to feel it happening, and yet real enough that scientists were able to measure it, cell by cell, using nothing more than the leftover carbon from bombs tested before most of us were even born. I want to be just as careful with you about what this slow renewal does not mean, because I think that honesty is exactly what makes the wonder of it trustworthy rather than overstated. This gentle background replacement of cells is nowhere near fast enough to rebuild a heart after the sudden, serious kind of damage a heart attack causes. When a heart attack cuts off blood flow to a section of heart muscle, a large number of cells die within a short window of time. And the slow, patient renewal we have been talking about tonight, that trickle of 1% a year at its very fastest, simply cannot keep pace with a loss like that. This is exactly why that kind of damage still leaves a lasting scar rather than healing over cleanly the way a cut on your arm does. Nothing in tonight's story is a promise that a damaged heart can simply mend itself, and nothing here should be read as a reason to feel less seriously about heart disease or the real sober danger of a heart attack. What this slow renewal actually is, instead, is something quieter and I think in its own way even more moving than a dramatic repair would be. It is a kind of background housekeeping that has apparently been running underneath your whole life, not built to rush in and save the day after a disaster, but built simply to keep gently tending to an organ that never gets a day off, not one, from the moment it first starts beating until the moment it finally stops. Consider what your heart is actually asked to do, day after day, without pause, without a lunch break, without so much as a single minute of rest across your entire life, beating on through every illness you have ever had, every sleepless night, every long stretch of stress you have ever carried. That kind of unrelenting work would wear down almost anything given enough time. It seems only fitting, in a strange way, that an organ asked to work that hard without ever once stopping would also be given some small, quiet means of tending to itself along the way, even if that means is nowhere near enough to undo the worst that can happen to it. Sit with what this actually means for a moment, because I think it deserves more than a passing thought. Some portion of the heart beating in your chest right at this very second is, quite literally, younger than you are. Somewhere in there are cells that had not yet taken their first beat when you learned to ride a bicycle, or walked across a stage to receive some diploma, or held a child of your own for the first time, or, for some of you listening tonight, a grandchild. Those particular cells arrived later, quietly, quite a while after all of that had already happened to you. And yet nobody would ever say your heart is somehow not truly yours because of that, or that it is some patchwork thing pretending to be whole. It is unmistakably completely your heart, still beating out your own particular rhythm, still carrying the whole of your one life inside it, the same as it always has. There is an old riddle sailors used to tell about a ship that stays at sea so long that every single plank in its hull eventually gets replaced, one board at a time, over years of repair, until not one original piece of wood remains. The question the riddle asks is whether it is still, truly, the same ship. I will not pretend to settle that old argument for you tonight, but I will say that a river offers a gentler answer than the riddle does. A river is never the same water twice. What flows past a certain bend today is entirely different water than what flowed past that exact same spot a year ago, and yet nobody stands on the bank and says it has stopped being the same river. It is the shape, the course, the steady, particular way it moves that makes it what it is, far more than any single drop of water passing through it ever could. Your heart, it turns out, has a little of the river in it too. It has held its own particular shape and its own particular rhythm through every year of your life, even while some small portion of what makes it up has been quietly, slowly turning over underneath that steady, unchanging surface. The beat you feel right now, this evening, is entirely your own, built from a lifetime of your own joys and your own worries and your own long, ordinary days, even though a certain fraction of the very cells producing that beat only joined the effort partway through the story. So the heart is not the stone monument you were handed at birth and told simply to guard until it eventually gave out on you, but a slow, living, quietly self-tending thing, gently renewing itself under your ribs even now, even in whatever decade of life you happen to be sitting in tonight, even as you listen to me talk about it. That does not erase anything serious about heart disease, and it is not meant to. But it does mean the old flat idea, the one that says your heart is simply handed to you once and spends itself down like a fixed and shrinking account until the day it runs dry, was never quite the whole truth. There has been a slow, patient renewal running underneath that whole story the entire time, largely unnoticed, doing its quiet work. Now, the part I always try to say plainly before I let you go, because I think it matters more than almost anything else I tell you. I am not your doctor. Nothing I have shared with you tonight is a treatment, and none of it is a promise about heart disease, about recovery from a heart attack, or about anyone's own particular heart. If you are worried about your own heart, for any reason at all, that worry belongs in a conversation with a doctor who can actually examine you, who knows your history, and who can look at your particular situation with far more than a video could ever offer you. I have not handed you a plan tonight because a plan was never what tonight was for. There is no supplement to take because of anything I have told you, no diet to follow, no exercise regimen. This changes. What I have tried to hand you instead is simply a truer and, I hope, a more wonderful picture of the quiet, faithful organ that has been keeping your time for you since before you can even remember, tending itself gently in ways nobody ever thought to mention to most of us. So before you go tonight, tell me down in the comments where in the world you happen to be watching this from, and whether any part of this surprised you, the way it surprised me the first time I sat down and read through exactly how those scientists managed to date the age of a living heart cell using leftover fallout from bombs tested decades before. Either of us was likely paying much attention to the news. I still find it a little astonishing that an era so full of tension and worry ended up leaving behind, almost by accident, the very key that let us finally understand something so gentle and so hopeful about our own bodies. If you would like to keep sitting with me like this, looking honestly at the quiet, ordinary marvels going on inside your own body, go ahead and subscribe, and I will keep bringing you these evenings, one at a time, always with the same promise of honesty over easy comfort. For now, I will just ask you to do one small thing before you turn this off. Lay a hand flat against your own chest, right where you can feel it working, and hold it there for a moment, however long feels right to you tonight. Feel that steady, unhurried beat. And know now what most people never get told, that some part of what is beating there tonight arrived later than the rest of you did. Quietly built, cell by patient cell, by a heart that has never once stopped tending to itself, for as long as you have been alive to feel it, and that will likely keep on tending to itself. Gently, long after tonight is over and you have forgotten you ever heard any of this at all,